Hello guys, welcome to the class. In this video, I'm going to perform analysis and design of multi-storied building in STAAD.Pro, and it is a G+4 building, and I will be first modeling the building in STAAD.Pro and then I will perform analysis. Then I will design a structure member. That is, I will only design column beam here. I have because slab is designed manually. So let's get started. Here I have framing plan in AutoCAD and I will model the building according to a framing plan. Framing plan is basically a structural member plan which does not include any walls or anything else. It just include column and beam position. I will model the same building in STAAD.Pro. Let's get started. Now I will open a STAAD.Pro. Let's create a new project. Select output location and click on next. Click finish. Now I will model a building. First I will create a origin point. Then I will go to the AutoCAD drawing. The another column is at 4.25 meter. So I will just model it very fastly because I have covered this concept in my previous video as well. Watch my previous video for more details. So I'll just model it very fastly. This is 4.25 meter, 5.995. See from the top view. Select all the nodes. Ctrl C, Ctrl V. This is Z. This is a Z axis. Here you can see. In AutoCAD also I have kept this as Z axis. 5.995. Okay. So it has just been created. So one node is at, what is the distance? 6 meter away from this node. Oh, sorry, Ctrl Z. X. So -6. Yeah, new node has been created. And then at a 4 meter distance, I'll go to air view from plus Z and design this are Ctrl C, Ctrl V. Here you have 4 meter, 4 and 5 meter. This along Z, 4 meter. Now it is created. Now see the plan. Here is one column and it is 8.5 meter away. Another column is also there. 8.5 along positive X. Then finally there are remaining 3 columns. I'll select all the nodes using node cursor. Node cursor is activated. Ctrl C, Ctrl V, and this is Z direction. What is the distance? 5, I think. Yeah, this is 5. At the distance of 5 meter. 5 meter. Click enter. Yeah. All the nodes has been created. Now I will join it using a beam cursor, and that is I will create a beam. Yeah. Before creating beams, let's see it in isometric view. So refer our elevation plan. So this is the natural ground level. No. This is the natural ground level, and we have ground floor 1 meter above the natural ground level. So Now select all the nodes, go to the transitional repeat and y, that is -1, because this is, if it is our ground floor, then we are below 1 meter the ground floor to reach the natural ground level, where we will fix our support. So from here it is clear that ground floor is 1 meter above the natural ground level. So I have kept here -1 because we are going in negative direction. Yeah, you can check. Now in this position I will draw a beam. In isometric view, it is better to draw beam in isometric view. You will get clear visualization. You can join it manually, or this is a small structure, so we can join it manually, beam by node by node. So this is our ground floor. This is our 5-story building. So, and I assume all the configuration of building is same. So I will extend all the column and beams same it is in frame plan to all the floor levels. For this I'll go to the front view. Using beam cursor, I'll select all the beams, see it in isometric view, go to the transition repeat. How many floor we need? 5, and each of 3 meter. This is our elevation view. We have G+4 building, and 1 meter is the foundation depth, let's say. So each floor height is 3 meter. Every floor are having uniform height 3 meter, and the total height of building is equal to 16 meter. Here you can see. Our building total height is 16 meter. Yeah, 1 2 3 4 5. Here I have just model a building that is G+4, that is a 5-story building. Here you can check it in AutoCAD. So we have completed modeling of our building in STAAD.Pro. This is how we model our building in real project as well. According to our AutoCAD plan, we prepare a framing plan, and then we will model the framing plan in any analysis and design software such as STAAD.Pro, and then after modeling the building we'll perform the analysis, and then finally we'll design it. So now the modeling has been completed, so I need to define support here, and then define the beam and column size. So let's define it. Member properties. Before defining member properties, I'll just assign a fixed support here to our building frame. For this, click on node cursor, go and select all the nodes. Check it in isometric view. You can see all the nodes has been selected, and then assign. I will again select all the nodes, and if we select from this plot plus Z, then all the nodes will get selected in that view. So assign to selected Now assign has been applied to the our building model. Now I will define member size. I will define, I have assumed here 300 by 450 mm column size. So this is 450 mm, 0.450 meter, and this is 300. This is for column, and then for beam this is 450 and this is 230 mm. Just add it here, and this is for column. First select, go to the select and select beam parallel to Y. All the column has been selected. Now assign to the selected beam, assign. Column size has been assigned. Again go to the select beam parallel to X, select beam parallel to Z, then assign the 450 to 230 mm to the building model. You can check its 3D rendered view, which is you can drag it by clicking left, by the left click. Go to the general. Now I'm going to define a load cases. So in this way, here I will just define dead load and live load. Add loads. Again go to the dead load and add the load. I'm adding here self weight because self weight is necessary, and I will add self weight as -1. Sorry, I have added it twice. Delete it. Go to the dead load, add. Now here I am going to add a member load. That is, I am going to add the wall load. For 9-inch wall, the dead load of the wall will be 11.26, and for 4-inch wall it is going to be 5.63 kilonewton per meter as UDL. And then dead load of for slab, I am going to add floor load. Dead load of slab will be for 150. Assume here I have assumed a 150 mm slab, so the dead load will be minus 4.45 kilonewton per meter square. For floor load, we need to define the Y ranges. Just by defining Y range, we can apply this slab load into our building. So here it is Y level is at 0. No. Here Y is at 0, and then here it is at 15. So this is minimum and maximum is 15. Click on add. This is when you see here floor load has been applied. Floor load has been applied to all the floors in our building model. So by clicking Shift F, you can hide and show. Now I will assign a wall load. This is a external wall. The minus 11.23 is for external wall. So according to building, I will assume all this wall as external wall and all this as internal wall. And let's see here. To select all the external walls, I'll go to view from +Y, then I'll select press Ctrl and then click all the external beams where we are going to apply the external wall load. These are the external walls, let us assume, and check it is in isometric view. Here all the external walls has been selected and just assign to the selected view. You can see external wall load, that is 11.23 kilonewton, has been applied just now. So for applying the partition wall load, I will again go to the same plus y view from plus y, and I have assumed these all are partition wall, and I will apply the load of minus 5.63 kilonewton to all this member. Check it in isometric view. Yeah, all the beams has been selected. So because the wall load is coming to the beam, and from beam to the column, and from column to the, it will transfer to the footing, from footing to the ground. This is the mechanism of load transfer in the structure. All the loads has been applied, external wall load and partition wall load. Now I will apply a self weight to the view. Now dead load, all the dead load has been applied. So I am going to add live load here. According to IS 875 part 2, live load for residential building is 2 kilonewton. So in 2 kilonewton per meter square. I need to define the range of the live load. I assume the whole live load is going to act throughout the building. So I just select this node, that is y at 0, minimum value is 0, then this will be our maximum value, that is 15. Just close this, add. Now the live load of 2 kilonewton is applied throughout our structure. So I'm going to add another load cases, which is very important. We need to define the load combination. According to IS 456-2000 table 18, different load combination are given, but in this case I will just define a single load combination, that is 1.5 dead load into live load. In any design and analysis of a building, we need to define load combination, because every load are acting together, so load combination is compulsory. I have seen in the most of the videos no one are taking the load combination, and that is a not good way of doing a building analysis. So here I will just consider 1.5 dead load plus live load, which will be applied to our building frame. So now do the analysis, add here, go to the analysis and run the analysis. It is necessary that after modeling the building, we have to do the analysis before designing, to ensure that there will be no errors and warnings. All the warnings and error should be handled, and before doing the designing, we need to check the warnings and errors value. The analysis is completed. Now from here you can see the report, analysis report, that is shear force, bending moment, everything you can see. So in this video I am going to cover the design aspect. In our case we are using IS 456-2000. This is an Indian standard code for reinforced cement concrete. So select parameters. I will select here some important parameters. Fi main, I will just select two parameters and click on OK. I need to define the parameters. I assume it is M25, that is M25 concrete, which is having compressive strength of 25,000 kilonewton per meter square. Click on add. Fi main, I will assume Fe 500 steel grade. So and commands. Go to the command and add design beam command and design column and take off. This is for calculating total volume of concrete and weight of reinforcement. So click on add. So apply, assign concrete grade to whole view and then steel grade to whole view. For beam and column, go to the select beam parallel to X, select beam parallel to Z. This is for beam design. So assign to selected view. Now go to the column, go to the select beam parallel to Y. So then assign it. Now this is column, this is beam, and this is for column. So now I am going to run the analysis command in STAAD.Pro. Here you have seen 0 errors, 13 warnings and 1 note. So view the output file. Let's check what are the warnings. Section failed while detailing. And this means that some beam member has been failed, like this beam 22 has been failed, and this is warning. One column is failed, column number 8 has been failed. So I am going to revise the dimension of beam, of all the beam. And the column size, this is column number 8. Now I am going to define a beam having dimension greater than the previously defined dimension. Previously I have defined 230 by 450 mm beam. Now I will define, now I am going to define YD. This is, let's say this is 550 and let's say this is 300. Now I am going to define this beam. Select all the beams because I am going to revise all the beam section, and this is just for understanding, and the purpose of this video is to learn what are the practical difficulties and what are the things to need to be considered while designing it practically. So when the member failed, we just select the particular member and change the size, and while construction it will be difficult because it will, if some beam is having different dimension. So here I will just change the whole beam size. Now I have changed the whole beam size. Again I am going to run the analysis. Here only 2 warnings are shown. Now again, previously there was 13 warnings, now only 2 warnings. Go to the warnings. Again, reinforcement percent exceed means that is, this is the inadequate column size. Column 4 and column 8 are failed. So go to the select by list 4 and 8. These 2 columns are failed. So when I revise its size, and then it will pass the test. For this column only I am going to change the size. Again go to the member property, go to the prismatic rectangle. Let's change the size as 450, 0.450, 0.450. Yeah, add it, and let's select these 2 beam. This is beam 4 and this is beam 8. Sorry, yeah, this is beam 8. Just select these 2 sections and assign the newly revised dimension of column. Again run the analysis and let's see. I think now every member will pass the test. Again, reinforcement percent exceeds 39 column number 39. Go to the select by list beams, type here 39. This member has been filled. I will again revise its size, general to this. The member which was filled was 39. Yeah. Again go to the analysis. Now here you are again seeing one warning. So here likewise again the every member are getting filled. Now I will change the whole column size as 0.45 by 0.45. For this I will select, because while design also we might get such types of problem, so I am showing you here. Now for ignoring, I am just going to change the whole column sizes 0.45 by 0.45, because our member has, because the STAAD was showing the section was not adequate, so I have just revised the all column sizes 0.45 and 0.45. Again I will do the analysis. See, yeah, there are no errors and no warnings. That is, our design is completed and all the members has passed the design checks, and this is what our ultimate purpose is. By clicking any member, go to the concrete design tab and you can see the our size of that member, that is, and this is the AST area of steel, that is 1367 and it is 0.79 percentage. So in this way we can see the column, and click this beam, go to the concrete design and you will see the reinforcement value, that is STAAD is by default it would recommend some dimensions of bars. For viewing the detailed report, we need to go to STAAD output and select on concrete results, go to the concrete design, then this is the concrete design report for beam 300 by 350 mm size. It is showing reinforcement area and this much, top reinforcement and bottom reinforcement. It is also recommending the 410 mm dia, one layers like that, and at the end I'll go to the end. Yeah, it is also showing the column design results for column number 65. It is giving a required steel area 573 and then concrete area this much, and see here main reinforcement provide 812 mm dia 0.45 percentage. It is showing here. Finally you can see the concrete take-up volume, that is the STAAD will predict total volume of concrete and the dia of bars in the report. I think I have covered all the aspect of analysis and design of multi-story building according to IS 456 2000 recommendations.